I think he's gone. Then Mr. Jagdish.
But you have to unmute them, na? I think they are on mute. Yeah.
Sir,
yes,
मैंने
okay,
उनको
fine.
I have allowed them
now,
to talk,
okay,
sir.
fine.
हाँ. Mr. Jagdish, you would like to ask a question since you have raised your hand?
Okay, fine. Go to next one, please.
Yeah. Mr. Selvan. Mr. Anis.
Yes. I have a question. Hello.
Anju, yes.
Yes. Sir, good afternoon, sir.
Yeah, good afternoon, Anis.
Are you able to hear me?
Yes.
Yes, we are able to hear.
Sir, I want to know, when we are going to do a comparative study, say for example, it is not like post-training and the pre-training and all. So two different populations, and if you are going to make a comparative study, so in such a case, what is the procedure and what test we can do it?
Yeah, so in case if it is a comparative study and you have two populations, so the thing is now depends on which particular test you do. It depends on the parameter which you are measuring. In case if your parameter is continuous in nature and you have two populations to measure, to compare, so again, so it would be T test that you'll be doing. Okay. Yeah. In case if the parameter which you are measuring is not in terms of continuous variable, it would be, say for example, it is in categorical form. So then we'll go for chi-square test.
Okay, sir. Sir, I raised a question that when we have two scales, we can apply, that is, we can apply a correlation. Other than that, what test we can apply, sir?
Other than
other than correlation, what
now,
test we can apply, sir?
No, see, try to understand, Anis. What is important is your objective. In case if you have two continuous variables, okay, two scales variable, and you want to see the relationship between these two variables, okay. So then you will either go for Karl-Pearson coefficient of correlation or some other non-parametric test, for example, Spearman rank or Candle tau. But now, in case if, then you will check the normality of the distribution, like normality of the data of these two continuous variable. So both the variables have to be normally distributed if you want to go for Karl-Pearson coefficient of correlation. Okay. So in case if they are any one of them or both of them is not normally distributed, then you cannot go for Karl-Pearson coefficient of correlation. Then you'll go for Spearman rank or Candle tau.
Okay, so we have to first test that is we have to go for the normality test, and then we have to see which test is applicable for that.
Absolutely correct. Absolutely correct.
Thank you very much, sir. Thank you. Thanks a lot.
Thank you, sir. I just identified now. Next one, it is Dr. Sunil Chavan. Dr. Sunil. Then yeah, Dr. Sunil.
Just mute. Just mute Anis Akhtar, please.
I'm doing it, sir. I've done it. Dr. Sunil.
Dr. Vikas,
then we
next.
have Dr. Vikas. Dr. Somesh Kharappa, sir.
Soma Shekharappa.
Soma Shekharappa, sir. Then Dr. Sanjit, sir, you have a question?
Yes, ma'am.
Yes, sir, please. Yes,
good
sir,
afternoon, all.
Good afternoon, sir.
My question is, uh, what is continuous data? Like a continuous function, continuous functions are the functions domain is set of real number like this. But in case of continuous data, if you take numbers, that is in case of functions that may not be continuous. But data may be continuous in a number system. In real number system is required, or any number is continuous data.
लिंक में वही नंबर इधर
सोमा शेखरन को प्लीज वो म्यूट कर लें आप.
Okay, bye. Thank you.
Yeah, Dr. Sanjeet.
Okay.
See, yes, you are absolutely correct. It actually have to follow that continuous function as well. It has to be absolutely, continuous as far as the real numbers are concerned, because it is, when we call it as a continuous data, it has to be numeric. That is first. But the second thing is, when I say continuous, that it can attain any value in the continuum. Okay, that means that any decimal point, anything. But what if you are, you have not collected the data in a continuum? Say, for example, weight. You are not taking weight in decimals, for example. So whatever the round number that comes, so that you are considering, not the weight in decimals. So in that case also, we can call it as a continuous data, because we are considering it as a continuous data. It can attain values, that is different issue, that is different case. But we have recorded the data without decimals, that is different issue. Okay, otherwise it's a continuous data. So whatever, so you, all the definitions which you are saying are related to continuous function, yes, you are right, it has to follow that. But for social sciences and for management researches, we call all the numeric data which has got some meaning of the mean, standard deviation and variance, we call it as a continuous data.
That means if we round up or etc. in the decimal places can be converted to some numbers, then it will be continuous.
No, it is continuous, sir. I'm saying, see, sometimes you say, see, we call it as a continuous data, but we actually, when we apply the continuous function on that, we do not find it continuous. So that is fine, that is okay. But by nature, by the characteristics of the data, then in case if it is in decimal points, that would be more ideal data if it is in decimal points.
Okay. Thank you very much, sir.
Yeah. Anyone else?
Sumanjeet sir. Sumanjeet sir. Dr. Sumanjeet sir.
Okay, fine. I think no one is there. So let
Sir,
me start.
then we have Dr. Sunil. Dr. Sunil, I think, has already asked the question. Dr. Sunil is there.
Okay, leave it. In case if someone needs that, they'll raise.
I think there is a question in Q&A box. I'll just take up that one. Let's take one or two from there then.
Okay.
Just a minute. There was a question that was flashing in the. There's a question being asked by Dr. Krishna Kumaran, sir. He's asking, can you explain when the difference between Whitney and chi-square test is used?
So we will discuss right now.
Yes, sir. That we'll be taking up. Yeah. Okay, sir. There is no more questions, sir. We can continue with the session, sir. Thank you.
Okay. And I request the participants as well, please do not write their questions in the chat box, because I have seen so many questions. Can you explain why difference between Whitney and this? Good afternoon, sir. Amulya Kumar, that is fine. So there are so many questions in the chat box as well. I request you to please write your questions in the Q&A.
Yes, sir. That will make the things easy for us, because finding questions from Q&A and wishes, it becomes very tough. We miss the questions sometimes. Over to you, sir. Thank you.
Okay. Great. So let me share my screen first.
Yes, sir.
Yes, can you see my screen?
Yes, sir, your screen is visible,
Yes,
sir,
yes,
and
yes.
you're
Okay.
completely audible, sir.
Okay, that's great. Thank you. So let's start with the tests, etc. So now we have understood where to apply which particular test. Okay. Uh, and we have also understood, what do we mean by one sample and two independent samples, two paired sample. Now, what is two independent sample? As someone actually asked this question in the chat box, I have read that, the two independent samples means when one population means one particular category is not impacting the other category. So that is called two independent categories. So two independent categories will become two independent samples because both of these two categories are actually representing their own respective population. Okay, you got my point. So that is why, for example, male and female, these are two categories which are representing males population and females population. So these two are the two different samples of male and female, and these two are independent of each other. That is why we call it as a two independent sample. Just a minute. Okay, so let's start by our, let's look at our PPT. So this is the PPT which we have to follow as far as our tests are concerned. Uh, as far as the parametric tests are concerned, yes, you will be following and applying parametric test when you are done with the conditions part. Means you have actually checked all the assumptions. In case if those assumptions, those conditions are being satisfied, only then you can go for parametric. Otherwise, you'll go for non-parametric test. Okay. Okay. So now let's talk about one sample test. Now, one sample is something which you all know. Now, what is one sample? One sample means the entire sample has been taken into consideration and there is no category. Okay. So in case if you look at the kind of, in case if I one sample, then how can I compare this one sample with other sample? I'm not comparing two populations. I'm not comparing two samples. So what does that mean? Mean like one sample. So one sample is actually a test wherein you are actually comparing the outcome of your experiment or your procedure with one particular value. You got my point. For example, you want, again, because the kind of example of that desi ghee manufacturing factory I gave, where you want to compare the uh, the mean value of all the weights of ghee packets, okay, that they say ghee packets with 1 kg, because that was being claimed. So in one sample t test or in one sample test, what happens that you really want to compare the mean value with the claimed value, which is important. Okay, with the claimed value. So what is the claim value? Claim value is 1 kg in case of ghee packet. For example, let's take another example of one sample one sample t test or one sample non-parametric test. So what is that non-parametric called? And we will discuss about that. Okay. So say for example, there is an ambulance company which says that wherever the emergency in a city is, okay, you get, in case if you meet with any accident or any medical emergency, okay, then our ambulance will reach there but within 8 minutes. Okay, so the maximum time is 8 minutes. Okay, so this is what is being claimed by ambulance company. Okay, so so the claimed time is 8 minutes. Okay, so now in case if you take the previous, say 100 or 200 rounds or the incidences wherein the ambulance started from its origin and then reached the medical emergency site, Okay, in that, so you actually have a 200 kind of observations of that particular ambulance reaching the accident or medical emergency site. So in that case, you have 200 observations and one claim value, that is 8 minutes. So then you will take the mean of these 200 incidences, and you will find the mean you know uh, mean time of reaching of ambulance to the accidental site, okay, or medical emergency site. So in that case, say for example, your mean value was 7 minutes and 34 seconds, but the claimed time was 8 minutes. So then how would you, test? What you will test? You will test whether the difference between 7 minutes and 38 seconds and 8 minutes, okay, is significant or not. So you actually test the significance of the difference between these two values. Okay, so that is what we call one sample test. So one sample means you have one sample and you want to compare it with the claimed value. So here, if I look at this particular PPT, so for metric data, metric means continuous data. Okay, metric means continuous data, and non-metric means non-continuous data, means categorical data. Okay, so if I see, so this is the weight, for example, okay, and see, this is the weight of the respondent, and a doctor wants to, a doctor claims that the mean weight, a doctor or someone, or say this may be the mean weight of the students or whatever, okay. So someone claims that the mean weight of this set of respondent is say 75 kg, okay. The mean weight is 75 kg. So this is what is being claimed by someone. So how would you do that? Then you actually go to, what you do. It's actually very simple in SPSS. And what you do here, just a minute. How can I hide this? Because this is showing me hide names of annotations. Yes. Now, if you say this, and if I go to analyze and see, I would like to test whether, this particular weight, this weight is being claimed as, the mean weight is being claimed as 75. So what you used to do in case of one sample t-test, you go to compare means and go to one sample t-test. It's like, this is the way that you do. So one sample, you go to compare means and go to one sample t-test, and then you actually take the weight here, this weight, and the test value that you will be writing here as 75. It's very simple. Okay, this is what you do, because you have actually claimed that, the mean weight of this entire sample is 75. Okay, so this is one sample t-test. Okay, and then you actually, and then you click OK, and then you get the result. But you can do one sample t-test only if it satisfies the condition of normality. So you actually check the normality of the data, normality of this weight. So how do you check the normality? You know it. You actually either check it by QQ plot, or you actually do Shapiro-Wilk test, or Kolmogorov-Smirnov test, or Anderson-Darling test. That is, Kolmogorov-Smirnov is the Lilly-4 test, actually, nothing else. So this is how you actually, test the normality of the data. But fine. So what in case you find the data is not normally distributed? So in that case, you cannot go for one sample t-test. So what the PPT says here, PPT says in case if it is not one sample t-test, and then you can go for Wilcoxon signed rank test. Okay. So what is the substitute of one sample t-test is Wilcoxon signed rank test. Okay. Now, what is this Wilcoxon signed rank test? That we are not going to get into the nitty-gritties and the calculations under these particular tests. What is important for us? Okay. What is important for us is the value of P. Okay. So we have a wonderful rule for us. And I think we all should remember these rules. However, nobody stops you in understanding the technicalities behind these calculations, be it t-test, be it ANOVA. You must know. That is the beautiful thing. Okay, but in case if you don't have that much of time, then what is the rule that you should always follow, either to accept or reject the null hypothesis? So the best rule, which actually I feel and I have made it very clear, is P high, null fly, and P low, null go. This is the wonderful kind of rule that I have जैसे वो सिखाया था ना उन्होंने what आपकी बार मोदी सरकार है ना, it's like that. So in the same fashion we have this as well. Whereas कुछ गड़बड़ी हो गया लगता है, हमारा सारा गायब हो गया. Okay, fine. So what is the rule here? How would you say? So in case if you do t-test, or you do Wilcoxon test, whatever test, Wilcoxon, or you do F test, or you do chi-square test, okay, whatever test, you get the value of, say, in case of T, in case of Wilcoxon, in case of F, you'll get some values of, say, here T, here F value, you will get T value, you'll get chi-square value. But in addition to that, you will also get P value, associated P value, always. And this is the beauty of all these softwares, okay? Be it Excel, MS Excel, be it R, be it Python, be it SPSS or MATLAB, whatever, okay? So you will also get P value. So when we are getting P value, then there is no worry about, thinking about accepting or rejecting null hypothesis. So what is the rule? P low, null go. P high, null fly. Now what does that mean? It means that in case if P is greater than P low, P is less than 0.05, then null go. We reject null hypothesis. Reject null hypothesis. P high, in case if P is greater than 0.05, null fly. Fly means accept. You can, so you accept null hypothesis. However, nobody writes as that accept is not to be rejected. There is a reason behind that, and let's not get into that. So let's write accept only, okay, just for the ease of understanding, okay. So so we reject null hypothesis and we accept null hypothesis. In case if P is greater than 0.05, when I say 0.05, I mean to say that I have 95% confidence level, 95% confidence level. It means 5% is the significance level, significance level. What does that mean? It means 5% is the type 1 error, तो हम इसको भी, let's not get into that, So what is important is at 9. So what is the important? At 95% confidence level, we test P value by 0.05. We compare P value by 0.05 at 90% confidence level. We compare with 0.1 at 99% confidence level. These are something which are, the convention, which is the convention, okay? So 90, 95, 99, we compare it with 0.01, okay? So, but most of the time, I think in 99% of the time, we use 95% confidence level. However, in the field of market and in the field of medical, 95 is something which cannot be taken. In the field of science, how can we go for 95%? We have to be 99.9% confident on a particular thing. Just think of the NASA's estimation of time of reaching at moon. So it has to be absolutely 99.999999% clear. Okay, so rather more than that. Okay, so it depends on study to study, but when we talk about social sciences, we talk about 95% confidence level, but nobody stops you to go for 99% confidence level as well. Okay, so we compare it with 0.05. 0.05. So P, if P is less than 0.05, we reject null hypothesis. Huh? And if P is more than 0.05, we accept null hypothesis. Huh? So what is important? Important is, have you made null hypothesis? Have you formulated null hypothesis? Only then you can accept and reject. Okay. So this is important. So what is the first step doing any hypothesis testing? You know, what is the first step? First step is formulate null hypothesis. This is the first step. Okay. So now here I would like to test the this one sample, that is weight. Okay. And this weight is not normally distributed. So I'll go for Wilcoxon signed rank test. So how can I do that in SPSS? Let's do that in SPSS. So just go to analyze and see here, just in the bottom, find something called non-parametric test. So different, however, in R, you just have to write a Wilcox function. So we are not talking about R and Python. We are talking about SPSS right now. Okay. So in non-parametric test, just press one sample, because it is one sample, and then go to field. Okay, it has to be like that only, and then go to field and take all these fields here. Why all the fields are here, I don't know. Okay, fine, and take weight here. Okay, so now weight is, we have taken as a test field, because, and why I'm doing this, because weight is not normally distributed. And then I'll go to settings. Okay, so here in settings, just it is already by default selected that automatically choose the test based on the data. Yes, I understand that, and I could do that, but the thing is, did I give the comparison value? I have not. So I have to go for customized test. So compare median to hypothesized Wilcoxon signed rank test. Can you see here? First, second, third, and fourth position. Just see. Compare median to hypothesized value. So hypothesized value. So what is the hypothesis? What is the hypothesis here? The hypothesis is weight is equal to, the mean weight is equal to 75. This is what was being claimed. So hypothesis is what is being claimed. Okay. So so I will write 75. So median. So here mean. So in case of non-parametric test, we cannot go for mean. So that is why we go for median. That is why it is non-parametric. And then, just press run. Okay. So should I again tell you? Cancel. Okay. I'll go to analyze, go to non-parametric test. Okay. Go to one sample. Okay. Then go to fields and take the fields, take the weight here only, because weight is the only test field. Okay. Go to settings. Okay. Go to customize tests, and then press compare median to hypothesis Wilcoxon signed rank test, and press and write 75, because we are claiming that the mean weight is 75, and then press run. Okay, so it is taking time. Non-parametric tests take a bit of time. Okay, so in case, so this is the beauty of non-parametric test in SPSS, that it also formulates null hypothesis for you in case if you forget, because there are cute researchers who really forget to formulate null hypothesis, and then they do the test. Okay, so the median of the weight equals 75. So this is what was uh, what we have what we have done, we have formulated the null hypothesis. So that was the null hypothesis. And what is the p-value? The significance. So SIG is nothing but the significance value. So this, and the significance value is actually called probability value, that is p-value. So what is, okay, uh, uh, what is the simplest way to understand p-value? The simplest way to understand p-value is, what are the chances? Now, what is p-value? I'm just telling you. What are the chances? What is the what is the probability? What is the probability that the result which has come? What is the probability that the result which has come is by chance? Okay. What is the probability that the result which has come is by chance? And you said the probability is less than 0.05. If probability is less than 0.05, it means the result which has come is not by chance. Okay. So it means there is difference. Okay. And nothing else. Okay. Now, so in case if we see the probability value here, p value is 0.05, so we reject the null hypothesis. And what is the null hypothesis? The null hypothesis is the median weight equals 75. No, median weight is not equal to 75. So this is something which you need to understand. So what is the median weight? You calculate the median weight and you would say this is the median weight, not 75. Okay. So this is something, one sample t-test when you really want to, not t-test, this is one sample Wilcoxon signed rank test. Okay. Because you are comparing it with some value. Now, the question comes, what if the data is categorical? How would you do the one sample test? So there are two ways of doing one sample test in categorical data. So if you see here, this is a categorical data, male and female, and you would like to compare it. Now, how can I compare it with anything? It is not being comparable, So, so there is another utility of non-parametric test is to actually test the randomness of this, variable. Means randomness means what? You know what happens in medical field, means doctors who actually do researches and all. It is very important that the selection of this sample has to be absolutely random. Okay, it should not be biased. Okay. However, this is the case in ours, in social sciences as well. But we usually do not test the randomness of the categorical variable. You must be thinking of, okay, what is this randomness I am talking about here? Randomness is this. You can see here male, male, female, male, female, male, male, and then female, female, female. Whether when you took this sample of male, female, and it's not about one, second, third. It's not like that. You can write it together as well. But the thing is, what is important, when you selected these males and females, whether you were biased or not. So I would like to see the randomness. So it actually makes a distribution and test the randomness. Okay, so there is a way of testing the randomness, and non-parametric test is the way of testing the randomness of a particular variable. Okay, so in case if you ask, sir, how can we ensure without even testing, how can we ensure that our categorical variable is randomly selected, is a random variable? It is absolute random. Here, the best way is to actually select the random sample is use, simple random sampling technique or use probability sampling technique. In case if you use probability sampling technique, then the chances are very, very high that you are using a random sample. Okay, that your categorical variable is random. Okay, otherwise you can test as well. People who are doing and writing thesis and all, they should always give the randomness they should also show the randomness of their categorical variable always. So let's test that. So just go to analyze and go to known parametric test, and this is one sample, right? This is one sample only. One sample means this is just, a one variable, that is gender. I'm taking all this sample together. And now here in objectives, just see here, what is the test sequence for randomness? Test sequence for randomness. Go to field, and what is the sequence? Sequence is gender. Take the weight here and put gender here. Okay, and then go to settings, and then you should not compare it with, now I do not need that, test sequence for randomness, this is runs test.
Sir,
yes
सर हम थोड़ा सा क्या ये इसकी स्क्रीन पे विजिबिलिटी थोड़ी सी फाइन कर सकते हैं सर? थोड़ा अमाउंट्स और वो कम दिख रहे हैं सर.
क्या दिख रहा है
सर? विजिबिलिटी थोड़ी हम शार्पन कर सकते हैं?
visibility sharpen?
Is it possible, sir?
I think visibility is the property of the
सर मैं स्लाइड की बात
audience
कर रही हूँ.
computer slide.
हाँ, कि स्लाइड पे सर जो दिख रहा है ना, उससे थोड़ा सा उसमें ब्लर आ रहे हैं फिगर्स और वर्ड्स एंड एवरीथिंग. कैन वी मेक इट बेटर सर?
This slide?
यस सर, थोड़ा सा. ठीक है सर, इट्स ओके ना.
वो ब्लर इसलिए होगा, वो वहां पर थोड़ा नेटवर्क का इश्यू होगा.
ठीक है सर, ओके, थैंक यू सर.
इसका
बिकॉज़ आई एम गेटिंग सम request in the chat box, that's why
I think वो जिनके पास जिनको ये प्रॉब्लम आ रहा है, they have a issue with their network because it has nothing to do with my computer actually.
Okay, fine. Thank you sir.
Okay,
I'm sorry for the interruption sir.
It's okay man. Okay, so what I was doing here, I was testing the randomness of our variable, that is gender. Okay, this is the utility of non-parametric tests. Now people say that non-parametric tests are does nothing. They are just the substitute of parametric tests. No, they have so many things to do. Okay, so what I am doing, so what I have done here in the objective, I said test sequence for randomness, and by default it has actually taken test sequence for randomness. Okay, you can do that. Yeah. And you can also compare observed binary probability to hypothesize. So binomial distribution test, which we are not discussing. Binomial distribution is something which we need to study it separately. It's a separate topic and very big topic, very important and very big. Okay, so just press run. Now just see the sequence of values defined by gender male and female is random. Okay, so this is the the null hypothesis that we have created, we have formulated. So one sample runs test, it has performed. Okay, and what is the significance value? This is 0.639, which is greater than 0.05. Now what does that mean? So P high, null, fly. So we accept null hypothesis. What was the null hypothesis? The sequence is random. So we retain that. We accept that the sequence is random. So it means, then your question would be, sir, what if sequence is not random? And what is the benefit if the sequence is random? Now, the benefit is you can apply the results onto population. Okay, because it's random. If it is not random, it means there is a doubt that how can you reflect, how can you apply the results of this sample onto population. So this is the beauty of randomness. Randomness is very important. Same is the case with other variables. You can always test the randomness of these categorical variables. One more test of one sample which is very important is, वो आपको अगर आप समझने की कोशिश करें तो वो भी बड़ी अच्छी कमाल की चीज है. लोग उसे करते नहीं है. People do not do that test because they do not understand how to do that, and sometimes they do not even think of. And what is that test? Just see. Here in preferences, so there is a, so this ये मैंने ऐसे लिखा है, ये कुछ आपस में related नहीं है. Okay, just say preferences of these respondents. So say preference of a particular brand of car. Okay, Hyundai, Maruti, Tata. Hyundai, Maruti, I think there are three brands. Okay, so this is one sample. So preferences of respondents. Now you would like to test whether people have uniform references or there is difference in the preferences. People have uniform preferences or there is a difference of preferences. Okay, in the same fashion. अब इसको मैं दूसरे शब्दों में बोलता हूँ. Whether the preferences are taken at random or there is some select pattern into it. If it actually follows a pattern, it means there is a difference of preferences of people. Just आपने कुछ नहीं किया, आपने सिर्फ देखा कि लोगों का प्रेफरेंसेस क्या डिफरेंट है या सिर्फ यूनिफॉर्म है, रैंडम ऐसी है ये बाय चांस. तो उसको टेस्ट करने के लिए आपने क्या किया, आपने वन सैंपल टेस्ट किया काई स्क्वायर का. हाउ वुड यू डू दैट? ये सब मैंने लिखा है, जस्ट सी हियर. यहाँ पर ये मैं आपको पीपीटी दिखाता हूँ. नॉन पैरामीट्रिक, यस, जस्ट सी. यहाँ पे देख रहे हैं काई स्क्वायर टेस्ट ऑफ गुडनेस ऑफ फिट and runs test and binomial. So binomial is two variables which we have done as of now. Okay, chi-square test of goodness of fit. Now this is the same. Now कैसे करेंगे आप इसे? You'll go to analyze. Okay, go to non-parametric test and one sample. Okay, and then go to objectives and automatically compare the observed data. Also test sequence for okay, whatever इनके आप कुछ भी कर सकते हैं, customize test कुछ भी कर सकते हैं आप. Go to field. Okay, इससे कुछ फर्क नहीं पड़ेगा क्योंकि वहां आप changes कर सकते हैं बाद में. Okay, now go to this brand preference, है ना, brand preference. And then go to settings and you cannot do this runs test of randomness because runs test can only be applied when the number of categories are 2. Okay, just 2. That is dichotomous variable. So dichotomous variable means when the number of variables are, number of categories are only 2. Okay. Now here is this is the test. Compare observed probabilities to hypothesized. And what is hypothesized probability? Hypothesized probability is the selection, the preferences of various brands is uniform, means it is random. It has nothing to do with okay, one is being preferred more than the other. So let's see that. Just press run. Now here, just see the categories of brand preference occur with equal probabilities. The categories of brand preferences occur with equal probability, but that was not the case. Why? So one sample chi-square test. आपने कभी सुना भी नहीं होगा one sample chi-square test. आपने सिर्फ chi-square test सुना होगा, है ना? Because people do not understand. People think that non-parametric tests are only meant for substitute of this parametric. No, it's not the case. So this is one sample parametric test, very beautiful test and very important test. That the probabilities of preferences is not same. So and just think in case if 3 vaccines, say corona vaccine, there are 3 corona vaccines, vaccine 1, vaccine 2 and vaccine 3, and they have been given to 200 people. Okay, then in case if you want to see whether these 200 people are selected randomly or not, okay, then you will use this particular test. Okay, the probability of getting selected for each vaccine has to be equal. तो यहाँ पे पता लग जाएगा, in case if the null hypothesis is rejected, then we cannot compare 3 vaccines with each other because the probability was not equal of getting selected for these vaccines. Okay, so this is the case. So here one sample test has been happened, and it has been found that yes, brand preferences was not equal. It means people have different brand preferences for different brands. Okay, different brand preferences for different brands. So उसके लिए आप कैसे चेक करेंगे, कहाँ से चेक करेंगे, क्रॉस टैबुलेशन पे जाएंगे और वहां पर आप चेक कर सकते हैं डिफरेंट ब्रांड्स के लिए, है ना। ब्रांड प्रेफरेंसेस आप यहाँ से भी चेक कर सकते हैं, है ना। So this is how you can work on various the means brand preferences means the frequencies of each brands. Okay, fine. So this is one sample chi-square test, one sample t-test, or non-parametric Wilcoxon signed rank test. Okay. Now coming on to the second test, which is important here, is the two independent sample t-test. है ना, आपने किया था two independent sample t-test. And so what is the substitute of two independent sample t-test? Is the Mann-Whitney U-test, है ना, Mann-Whitney U-test. So where to apply two independent sample t-test? Where to apply two independent sample t-test? Yes, you are thinking right. Means when one variable is categorical and the other variable is continuous, and the categorical variable has just two categories, and we would like to see the relationship, then we will use one sample t-test. So not one sample, two independent sample t-test. So here, say for example, we have one variable as gender, and the other variable is weight. Okay, so one is categorical, other is continuous. Okay, and the categorical variable has just two categories, male and female. I would like to compare two independent populations, male population and female population, with respect to their mean weight. So comparing populations with respect to some parameter, continuous parameter, t-test, if the number of populations are 2. Okay. So how do you do it in parametric test? Very simple. Go to independent sample t-test. आप ऐसे जाते हैं, वहां पर जाकर के आप weight पर जाते हैं, और यहाँ पर जाकर आप gender पर जाते हैं, और यहाँ पर आप gender को define group कर देते हैं. You give group 1 whatever the coding that you have given, and then you just press OK. Simple. And then you get the result. Okay. But what if weight is not normally distributed? So in that case, you cannot go for what? You cannot go for two independent sample t-test. So what you can do then? You will go to non-parametric test and see, can you see here independent samples? Yes, press this. Okay, so compare, so automatically compare, come here, take weight here, okay, and take groups here, gender, okay. However, in case if you go to setting and just press this, automatically choose the test based on the data, then it will automatically choose the Mann-Whitney U test. In case if you just press this customize test, then you can also write, Mann-Whitney U test, that you can also press here. Okay, so let's test the SPSS. SPSS को टेस्ट करते हैं कि ये क्या करता है हमारे लिए. क्या ये Mann-Whitney U टेस्ट करेगा? इसी को ही सोचने दो, हम नहीं सोचते अपने बारे में. Okay, great. So just press run. बहुत समझदार है SPSS. इसने खुद ही देख लिया कि इसमें it has detected that we have two categories in the categorical variable, and the two categories are independent of each other. So the distribution of the weight is same across categories of gender. And so what he did a test of independent sample Mann-Whitney U test, and the value of P, significance value, is 0.783. Now what does that mean? P is greater than 0.05. So P high greater than 0.05 है ना, P high null fly. So we accept null hypothesis. So we retain null hypothesis. Okay. I hope things are clear. So what does that mean? So when we retain null hypothesis means yes, gender does not influence weight. There is no significant relationship between gender and weight. आपका ये प्रश्न हो सकता है, okay, you may have a question that sir, मैन विटनी यू टेस्ट एक पुअर टेस्ट है, कमजोर वीक टेस्ट है ना, so should we really rely on this test? So my counter question is, what is the option you have? Either you do not do any test or you do some test, because you are not authorized, you are not allowed to do t-test because your weight is not normally distributed, so you don't have any other option. ठीक है ना? अब अगर केक खाने के पैसे नहीं है और फिर आप पूछ रहे हैं कि सर रोटी खानी चाहिए क्या, what does that mean? Now do you have other option? You have just passive of eating roti, so you have to eat roti only. Okay, you don't have money to eat cake, then don't ask this question. Huh? So beggars are not choosers. But I don't mean my words. Huh? Okay, great. But having said that, let me tell you, they are the savior. Non-parametric tests are the saviors. Now, coming on to very important aspect of two independent sample t-test, we understand. Two independent sample means when one variable is categorical, the other variable is continuous. What if one variable is categorical and the other variable is also categorical? Then can you do t-test? No. Then do you have anything in your parametric test? No. बड़ा बोलते थे आप, हमारे पैरामीट्रिक टेस्ट बड़े स्ट्रॉन्ग होते हैं, कहाँ है वो आपके टेस्ट? अब वो भाग गए, क्यों? Because both the variables which we would like to see the relationship between are categorical in nature. We cannot do any t-test, NOVA, nothing. So in that case, why can't we do it? Because there is nothing called mean here. So just see, if I want to compare gender with smoking, is there any relationship between gender and smoking? क्या ऐसा है कि मेल्स ज्यादा स्मोक करते हैं या फीमेल्स कम स्मोक करती हैं? Is it so? We would like to see that. We would like to see the relationship. एक दूसरा एग्जाम्पल भी बन सकता है. Is there any relationship between profession and preference? Profession and preference, है ना? कि क्या ऐसा है कि बिजनेसमैन Hyundai को या मारुति को ज्यादा पसंद करते हैं या गवर्नमेंट एम्प्लॉई टाटा को पसंद करते हैं, है ना? Is there any association between these two? है ना? So that is why in chi-square test we actually call it as test of association. We call it as test of association. Are these gender and smoking are associated? So this is we call, so when the two variables are categorical in nature, we go for what? Chi-square test. So Sahab, let's do a chi-square test and see. So first of all, let's make a hypothesis. तो यहाँ पर हम जरा देख लें हम अपनी पीपीटी के कौन से पॉइंट पर हैं, ये देखिए ध्यान से. Two independent sample test में, in case if the data is metric, we go for two independent sample t-test. In case if the data is in ranking and medians, means data is not meeting the assumptions, we go for a Mann-Whitney U-test. But in case if the data is non-metric, that is nominal or ordinal, means categorical data, we go for chi-square test. We go for chi-square test. So let's do that chi-square test for two categorical variable. है ना? आई होप यू पीपल डोंट हैव एनी डाउट। चलिए पहले इसको करते हैं, फिर आपके क्वेश्चंस उठाते हैं अगर आपके कोई क्वेश्चंस हैं तो। Okay, fine. So let's go to analyze. Now, chi-square test, I would suggest that you should do from descriptive statistics, go to cross-tabulation. Okay. What is cross-tabulation? Yes, anyone? Cross-tabulation? Cross-tabulation. Yes, you are right. You are absolutely right. Cross-tabulation is when you make a frequency table of two categorical variables. Okay, when we make the frequency table of two categorical variable, we call it as a cross tabulation. ठीक है ना? Yes. Okay, so press cross tabulation and you can take anything. No, say for, and we would like to do the relationship between, check the relationship between gender and smoking habit. Yes. Now, what is the null hypothesis? Before doing the test that is chi-square test, we have to formulate the null hypothesis. What is the null hypothesis? There is no significant, means statistically significant relationship between gender and smoking habit. This is the one way of formulating null hypothesis. Is there any other way of formulating null hypothesis? Yes. Smoking habit is uniformly distributed over male and female, two categories. Yeah. Is there any other way of formulating null hypothesis? Yes. There is no influence of gender on the smoking habit. So whatever way, okay, you can do it. Now you may have another question. Sir, ये जो रो आपने रो में जेंडर ले लिया, कॉलम्स में स्मोकिंग हैबिट ले लिया, तो ऐसा कुछ किया है क्या? मतलब कि ऐसा कर सकते हैं कि स्मोकिंग हैबिट को रोज में ले लें और जेंडर को कॉलम्स में ले लें? यस. Is there any difference? No. कुछ भी आप किसी को किसी में भी रख सकते हैं. क्रॉस टैबुलेशन मीन क्रॉस टैबुलेशन. नाउ व्हाट इज द कन्वेंशन? है ना, कन्वेंशन क्या है? सर लोग क्या करते हैं? तो लोग ये करते हैं, ठीक है, that they take or they always take dependent variable, means the thing which you actually thinking of dependent, है ना, जैसे gender affects the smoking habit. So smoking habit is the gender, smoking habit is the dependent variable, है ना. So that is why, so gender affects the smoking habit, so smoking habit is the dependent, है ना, is presumed to be dependent. So you should take it in column. तो कहा जाता है कि डिपेंडेंट वेरिएबल को कॉलम में ले लें तो ज्यादा अच्छा रहता है. अच्छा बच्चा कुछ नहीं रहता है, बस ठीक है, थोड़ा रिजल्ट को और टेबल को देखने में अच्छा लगता है. टेबल देखिए कैसी दिखती है, अभी देखते हैं. तो हम इस एग्जैक्ट का कुछ नहीं करेंगे, ये एसिम्प्टोटिक है. मोंटे कार्लो या फिर एग्जैक्ट टेस्ट हम नहीं करते हैं. वो इसलिए क्योंकि एसिम्प्टोटिक हमें एक अच्छा सा वैल्यू दे देता है. एसिम्प्टोटिक का मतलब क्या होता है, मैं अभी आपको इसके बारे में थोड़ा सा बता देता हूँ. कंटिन्यूअस, सो हम इसको नहीं छेड़ते हैं. एग्जैक्ट स्टैटिस्टिक्स, स्टैटिस्टिक्स पे आकर के यस आई नीड काई स्क्वायर ऑफ दिस डेटा एंड, और ये सब चीजें क्या है, फाई, क्रैमर्स वी, लैम्डा, है ना, कैंडल टाउ, इसके बारे में भी अभी थोड़ी सी देर में बात करते हैं. कंटिन्यू. डिस्प्ले क्लस्टर्ड बार चार्ट, चलिए अगर हमको चाहिए तो हम बना देते हैं. सेल्स में हमको एक्सपेक्टेड फ्रीक्वेंसी भी दे दो, है ना, ऐसा कुछ कर देते हैं. एक बार देखते हैं हम क्यों मांग रहे हैं एक्सपेक्टेड फ्रीक्वेंसी है. कंटिन्यू कर देते हैं. और उसके बाद हम कहते हैं ओके. सो दिस इज द काई स्क्वायर टेस्ट, है ना. ये तो हमारा बार चार्ट हो गया, दिखने में अच्छा लग रहा है इसलिए बनाया, और कोई रीजन ही नहीं था. ओके, चलिए यहाँ पर हम देखते हैं, this is called cross tabulation. This is called cross tabulation. The gender versus smoking habits. So this is the cross tabulation. We can see, yes, male, is this 11, and male who smoke 11, and male who do not smoke are 31. So total males 42. Females who smoke 37, who do not smoke 11. So total 48. So total number 90. There's no missing, nothing. What is this expected count? Expected. So this expected count is what happens, how chi-square works. Chi-square works on observed frequency and expected frequency. Okay. And the formula of chi-square is, what is the formula? Yes, you are right. आपको पता है formula of chi-square, summation of observed frequency minus expected frequency whole square divided by expected frequency, है ना. So ये है chi-square का formula. You are absolutely correct, है ना. So in that case हमको expected frequency तो चाहिए था, तो however अगर हम इनसे ना मांगते तब भी ये तो कैलकुलेशन कर देता. ये तो हमने इससे मांगा था, जाकर के देखा है आपको. ये देखिए हमने यहाँ पर क्रॉस टैबुलेशन में, स्टैटिस्टिक्स में जाकर के, यहाँ सॉरी सेल्स में जाकर के मैंने कहा था एक्सपेक्टेड भी दिखा देना मुझे. मैं क्यों देखना चाह रहा था, वो इसलिए देखना चाह रहा था, what happens that your expected frequency has to be more than 5. देखें आप ध्यान से, यहाँ पर एक्सपेक्टेड काउंट कितना है 22. काउंट मीन्स फ्रीक्वेंसी. हाँ, सो 19 मोर देन 5. यहाँ पर 25 मोर देन 5, 22 मोर देन 5. अरे हर जगह मोर देन 5. इन केस योर एक्सपेक्टेड फ्रीक्वेंसी इज मोर देन 5, देन मस्त, सब कुछ बढ़िया चल रहा है, सब ठीक है. अदरवाइज देयर इज अ प्रॉब्लम. तो क्या प्रॉब्लम है उसके बारे में भी हम डिस्कस करेंगे. ओके, सो यहाँ देखें अगर हम ध्यान से, सो यहाँ पर है पियर्सन काई स्क्वायर. द वैल्यू ऑफ काई स्क्वायर इज 23. ओके, एंड asymptotic significance is 0.000. What is this asymptotic significance? What happens that for chi-square kind of tests, for any known parametric test, what is being presumed and what is being required from the researcher is that the researcher has to have sufficiently large data set. Okay, the sample size has to be very large. So this asymptotic significance means that SPSS has taken that your data is sufficiently large. That is why it is asymptotic. Asymptotic means I have assumed that your data was sufficient. Okay. In case if your data is not sufficient, if you think so, okay, then please do not do this Pearson chi-square test. Then do Monte Carlo test. Then do some Fisher exact test kind of. Okay. So this is asymptotic. So इसलिए हम इसको ना इग्नोर कर देते हैं. हम कहते हैं चलो छोड़ो ना, पता नहीं क्या लिखा हुआ है, asymp, significance ही पढ़ लेते हैं. But asymp means that SPSS is so kind to you. जैसे कहते हैं ना भगवान को, the God is so kind to me. In the same fashion, SPSS is also so kind to you. Okay, so here SPSS says your significance after assuming that your data is sufficiently large is 0.000. Okay, means p value is 0, and it has some value. It's not exactly 0. Okay, but I'm least bothered whatever the value is, but this value is less than 0.05. Now what does that mean? P low, null, go. Now what does that mean? It means null hypothesis gets rejected. Now what does that mean? Null hypothesis gets rejected. It means that Yes, you are right. Male affects the smoking habit. Means gender affects the smoking habit. Male and female have different smoking habits. It means this is the meaning. So and yeah, you know, and if you want to see uh, who smoke more, is it the male or female? So just see the value of yes and value of no. So what is the value of yes for smoking? What is the more value of yes? In case if we see female smoke more than males. So here this is what my data says. ना याद रखिएगा आपके कोई भी रिजल्ट आए तो आप नहीं बोलोगे कि आपने कहा है आपने नहीं कहा आपका डेटा ऐसा बोलता है यस राइट ग्रेट नाउ द क्वेश्चन इज व्हाट इज द स्ट्रेंथ ऑफ रिलेशनशिप ये तो पता चल गया कि जेंडर तो वाकई में इन्फ्लुएंस करता है स्मोकिंग को है ना जेंडर तो वाकई में एक चीज और बताना भूल गया मैं आपको यहाँ पर कहाँ लिखा हुआ है ये लिखा हुआ है ये तो मैं बताना ही भूल गया आपको ये देखिए ध्यान से यहाँ क्या लिखा हुआ है आपने भी नहीं पूछा ये देखिए 0% means 0 cells have expected count less than 5 the minimum expected count is 19 ठीक है so what does that mean it means that it is saying कि सर बहुत अच्छा हो गया no cell of yours has an expected count expected frequency less than 5 very good thing now what if your expected count is more than 5 is less than 5 ये भी तो एक बहुत बड़ा प्रश्न है ना कि what if your expected count is less than 5 आपका ये प्रश्न है कि सर अगर ऐसा हो गया तो हम क्या करें है ना तो यहाँ पर हमारे पास दो चीजें हैं in case if you have 2 by 2 matrix means अगर आपके दोनों categorical variables have only 2 categories means 2 by 2 है ना देख रहे हैं आप ध्यान से जो क्रॉस टैबुलेशन बनी है वो 2 by 2 की बनी है मेल फीमेल यस नो है ना जबकि यहाँ पर ये 2 by 2 नहीं है प्रोफेशन अगर हम ये देखते कि अगर हम जेंडर और प्रोफेशन में देखते तो 2 by 2 नहीं था यहाँ पे 2 है यहाँ पे 5 कैटेगरीज है 2 से ज्यादा है तो in case if the expected count expected frequency is less than 5 and you have 2 by 2 matrix means categories are not more than 2 then you should not see Pearson chi-square no तब आप Pearson chi-square नहीं रिपोर्ट करेंगे then you will report Fisher exact test ये देख रहे हैं आप यहाँ पर ये लिखा हुआ है ये देखिए likelihood ratio के नीचे है ना Fisher's exact test then you will go for Fisher exact test okay this is only in case of what 2 by 2 matrix okay now what if there is 3 by 3 और 2 by 3 means rectangle अब चलिए टेस्ट करके ही देख लेते हैं ना जेंडर और प्रोफेशन में देखते हैं कि क्या कुछ रिलेशनशिप है तो मतलब इस बात का मतलब क्या है इट मींस does a particular gender है ना selects a particular profession क्या ऐसा है क्या प्रोफेशन की चॉइस मेल और फीमेल आपका जेंडर क्या है इस बात पर निर्भर करता है ओके वी वुड लाइक टू सी दैट
Sir, sorry to interrupt you in between, but there is a continuous request by participants. We have few participants from South India. So if English can be followed as a medium of communication.
Okay, fine. But I'm using English only.
Yes, sir. Yes, sir. But a couple of times when you speak in Hindi, they are unable.
So when I speak in Hindi, let me tell you. So all my participants of South India, let me tell you. When I speak in Hindi, that is either not important for you or that has already been spoken in English or that will be spoken, that will be taken in English as well. So don't worry. So nothing you are skipping just because of Hindi. Okay?
Thank you, sir. Thank you so much.
So this is something for because I know. Okay, because I know. So I am quite surprised that how what is that thing which actually I have spoken in Hindi and not speaking and not spoken in English is something which is I'm quite surprised. So all my friends of South India, please rest assured, okay? In case if I'm speaking something in Hindi, that is not for you. That is for my North Indian participants. Okay. And not for you does not mean that is something which is, that not important for you. That is something that has already been said. Okay. The things I have already been told to you. Okay. So don't worry. So this is the way that I teach. Okay. So I think the majority of the things are only in English. Huh? Okay. So now coming on to the point here. Yes. Where was I? I got interrupted. I got disturbed. So yes, what I was doing. I was talking about. Yes. I was talking about, like, in case if the expected count is less than 5, okay? In case agar expected count less than 5 hai, okay? So in that case, what is the method that we actually have to apply? We have to see the Fisher's exact test, okay? Fisher's exact test. So in this Fisher's exact test, you will again see this significance value, not Pearson. So you will be reporting what? You will be reporting Fisher's exact test than Pearson chi-square. Okay. Now, what if you have, what if you have, say, Anjali ma'am, you disturbed me. This is something like, I was there, yeah. What if you have two variables, two categorical variable? One is gender and the second is profession. Okay. And Anjali ma'am, please ignore in case if someone writes that. Do not please interrupt like that. In case if someone writes that he is not able to understand and I'm using Hindi, please ignore that. I request you. Yeah.
Please, sir. Apologies.
Ignore, yeah. Please ignore. But this is something which is not accepted. Okay. So in case if those people who have some problem, they can leave this particular class. Okay. But this is something which I was in a flow, and but the thing, I am taking the things right from the beginning in English, and there's something which I speak in Hindi, which is just a repetition of whatever I've spoken in English. So this is something which is not accepted at all. So in case if there are some participants who are not able to understand, and in case if they even think that I'm speaking in, they can leave the class. Okay. And please do not disturb, because this is something which you are actually, you have actually broken the entire flow of mind and you have really disturbed. Please do not do that. Thank you so much. Okay. So I was talking about there's two categorical variables. One is, with two categories, and the other is there are three categories. Now here, the cross tabulation is 2 by 3. Okay. The cross tabulation is 2 by 3. It's not 2 by 2. Then you cannot go for Fisher's exact test. You will not get the value of Fisher exact test. Just see that. Let's do. Okay, go to analyze, go to descriptive statistics, go to cross tabulation. Okay, then instead of smoking habits, just keep it there and then go to profession. Okay, and then column. Now what happened? I would like to see the relationship between gender and the profession. Okay, now statistics is, again, chi-square. So I'm not putting these contingency, phi, Cramer's V, lambda, nothing. Okay, so just continue, and let's not even, okay, let's take the expected value as well, and let's not take this clustered bar chart. We do not need that beauty right now. Okay, so here is the value of Pearson chi-square. Okay, what is the value of Pearson chi-square? 7.6. And if you see the asymptotic significance, this is 0.107. Now, what does that mean? It means that this is more than 0.05. Now, what does it mean? Null hypothesis gets accepted. What does that mean? It means there is no influence. Yes, you're right. There is no influence of gender on profession. Means gender का profession पर कोई influence नहीं पड़ता है. Okay, so this is something which we have done with two categorical variable, the relationship between two categorical variable. Okay, done. Now here, can you see Fisher exact test? No, there is no Fisher exact test. So because I said that what Fisher exact test can be applied only when there is 2 by 2 matrix, means when both the categorical variable have what, 2 categories only. Okay. Now your question would be, sir, what if the expected count is less than 5? It is the case, I think, somewhere. I think let's see profession and preference. Let's see that. Analyze, go to descriptive, go to cross tabulation, take profession and profession. Okay, just reset it. Take profession here in the rows and brand preference. I would like to see the relationship between profession and the preference of the brand. है ना? देखना चाहता हूं कि क्या कोई profession brand पर असर करता है. So we would like to see that. So in that case, let's go to statistics and then calculate the chi-square test for that and continue and just say okay and see here. Now here it is saying, see, so this is the value of chi-square and this is 10 cells, that is 66.7%, have expected count less than 5. Okay, expected count less than 5. The minimum expected count is 1.34. So it means there is expected count as well, and an expected count is less than 5. Now what do I do? When the expected count is less than 5, we cannot rely on chi-square test. Okay, we cannot rely on chi-square test. So your question would be, sir, kya kare? What should we do now? You cannot do anything. In that case, you can only do one thing. You increase your sample size. You have to increase your sample size in case if the number of categories are more than 2 and you would like to see the relationship between 2 categorical variables. Okay, great. I hope now you understood the point. Now the thing is, your next question would be, sir, I understand that yes, there is a relationship between gender and smoking, or say there is no relationship. Now see, there is no relationship between gender and profession, that we have just proved, but we have proved also that there is a relationship between gender and smoking. As we know, in case of Karl-Pearson coefficient of correlation, when we actually calculate the value of R, then we also come to know how strong the relationship is, based on the value of R, which varies from -1 to 1. In the same fashion, can we also know the strength of relationship between gender and smoking? Means 2 categorical variables, and then you would like to see the strength of relationship. That is a counterpart of R. That is Karl-Pearson coefficient of correlation. What is Karl-Pearson coefficient of correlation? When you want to test the relationship between 2 continuous data, 2 continuous variables. Now here, gender and profession are 2 continuous variables. Gender and 2 categorical variables. Gender and smoking are 2 continuous variables. Can we see the relationship? Yes, we have just seen there is a relationship. Null hypothesis got rejected. Yes, we know that. Now, can we see the strength of relationship as well? Yes, we can. And that is, we go by what? We go by this. Phi and Cramer's V. Okay? Phi and Cramer's V. See, this phi and Cramer's V, this contingency coefficient, and this lambda. So lambda is something which, okay, let's do a lambda as well and see what would happen. Okay, let's see. Just press, okay, continue. And instead of brand preference, because brand preference there was no relationship, so why should we go for it? So there is gender and smoking habit, there was a relationship, and I would like to see the strength of relationship. Very simple. There was a relationship, I checked that, and I would like to see the strength of relationship. Agreed or not? Yes. Let's do that. Okay. Yes. So this is the chi-square value. Since no cell was less than 5, so we will not see Fisher's exact test. We will see Pearson chi-square. Okay. And yes, the value of P is less than 0.05, which means that null hypothesis is rejected, means there is a relationship between gender and smoking habit. Now let's see. Let's leave this lambda and see the strength of relationship between uh, uh, gender and smoking habit. First, see phi. What is the phi value? Phi value is minus 0.509. Now, when I see this minus 0.509, so this minus has nothing to do. Like in this minus will change in case if I change the cross tabulation from column, I put gender and that smoking habit in rows. So this value will change. So let's not get into this sign of phi, and let's see the 0.509. So 0.509. So the value of phi varies from 0 to 1. No, minus 1 to minus 1 to plus 1. Now what is this minus 1 to plus 1? Again, this value is uh, in case of higher the value, the more the closer the value is towards 1, the better is the strength between these two variables. So 0.5 is, yes, we have some mediocre kind of strength between gender and smoking habit. Okay, so this is the strength as well. So as you can, you are talking about the association between gender and smoking habit. You can also talk about the strength of association between gender and smoking habit. Okay. Now, what is this Cramer's V and contingency coefficient? So let me tell you. So Cramer's V and phi have the same value. Why? Because Cramer V is nothing but the upgraded version of phi. Cramer's V is the upgraded version of phi. So what is the difference? The difference is, if I want to test, just see. Just a minute. If I want to test the relationship between two categorical variables, that is gender and smoking habit, so there the matrix is 2 by 2. It has two categories in gender and two categories in smoking. Okay, so in that case we use phi test. But in Cramer's V, but in case when you want to see the strength of relationship between two variables, say for example gender and profession, where the other variable or any of the or both the variables have more than two categories, you cannot go for phi test. Phi test is only applicable for 2 by 2 matrix. Okay, so in that case you cannot go for phi test. You have to go for Cramer's V, which is an upgraded version of phi. Okay, so the interpretation has to be read in the same fashion. Okay, it's the same interpretation. Then what is this contingency coefficient? Contingency coefficient can be done for for any size of the data, means any number of categories, be it 2 by 2, be it 2 by 3, 2 by 4. So it has nothing to do with phi and Cramer's V. So contingency coefficient is another test of testing the strength of relationship. So it is more robust test actually. So you must be thinking, sir, ye do test kyun hai? Why there are 2 tests or 3 tests? Yes, this is as same as when you do normality distribution test, that's Shapiro-Wilk test, Kolmogorov-Smirnov test, QQ plot test, Lilly-Ford test, and Anderson-Darling test. So there's so many tests. You just have to follow one or two. In the same fashion, it's up to you which particular test you would like to go for. So this is Cramer's mean. Now, what is this lambda? Lambda is something which actually talks about is there any dependency relationship as well? Like one variable is dependent on another. So if you see here, so in case if you find there is a significant, gender is dependent, it says is significant, smoking habit is dependent, it is significant. It says that in case if we say that smoking depends on gender, then even then we are right, because lambda says that yes, it is a significant dependent independent relationship between these two categorical variables, nothing else. However, it hardly matters. We would not go for lambda, etc. Why? Because our theory says that, because in social sciences what is important is the theory. Your theory says that smoking habit depends on the gender. How come gender depends on smoking habit? Okay, so this is something which is lambda. And now your question may be, sir, what are these gamma, Somersby, candle tau B and candle tau C? This is, if you see here the heading, this is for ordinal data. You have categorical data, but the data is ordinal. Okay, so then you will actually go for candle tau B and candle tau C, and the way you read and interpret is absolutely same. Now, what is that data which is ordinal? See, this is the data which is ordinal. Can you see the age category? It is an ordinal data because we can put the age category into some order of ascending and descending age categories. So if you see candle tau B and candle tau C, in case if it is 2 by 2 matrix, then candle tau B. Okay, in case if it is 2 by 3 matrix, then you have 2 by 2 or 3 by 2 by 3, 3 by 3, or any rectangle shape, then we go for candle tau C, nothing else. So don't worry about that. So you can test the relationship between two categorical variables. Okay, so now let's talk about the third type of variable. Now third type, which is paired sample. Now, what is this paired sample test? Now, when I say paired sample test, paired means, as we have discussed in your questions, because so many people actually ask questions of what is this dependent variable. So dependent variables are nothing but dependent test means when you have one set of set of sample, but you are taking two observations, before and after. For example, you take test before teaching and then takes again test after teaching, and then you want to compare the difference between these two tests, the scores, test scores. So in that case, you would like to see, is there any difference, is there any impact of your teaching on the person or not? In the same fashion, this is see, weight before treatment and weight after treatment, or after training, whatever you call, weight after training. So and you would like to say, is there any impact of training? Means, is there any difference between weight before and weight after? So what do? You go for paired sample t test. ऐसा करते हैं ना? Compare means, and then you go for paired sample t test, and then you write weight before, and then you write weight after training, and then you press OK. Simple. And you do it. It's very simple. But what if you would like to test the paired sample using what if these two variables are not normally distributed? Then you'll go for what? Non-parametric test. Go to non-parametric test. Go to related sample. Can you see that? Okay, related sample. Field. Now field, weight, and then weight after training. Okay, then go to settings. Now, since it is a paired sample t-test, then either I would customize, okay, the test, and I would you know I would select the test on my own. Okay, for example, sign test or Wilcoxon matched pair rank test. So दो test होते हैं. So there are two tests: sign test and Wilcoxon matched pair sign test. So in case if you see that, uh, what is which test is the more robust test? I would say Wilcoxon matched pair signed rank test. So in case if I click on this, I will get the value. But fine, let me not do that, and let me ask SPSS to do it for me and automatically choose the test based on the data. And then I will say, in case if I do this, I will get the same result. So don't worry about that. So just press run. Okay. Now see, the median of differences between weight and weight after training equals 0. Means what is the null hypothesis? Null hypothesis, there is no difference of training, that the mean weight of before training and mean weight after training is same. That is, the difference of mean weight is 0. So this is the way that you narrate your hypothesis. That is null hypothesis. Here, so what I wanted to check whether there is impact of training or not. So here the p-value is less than 0.05, which means we reject the null hypothesis. And what does that mean? There is a positive impact of training on the weight of the respondent. So this is how you will be doing your paired sample. So what is the name of the test? Wilcoxon signed rank test. And it's been written here as well. Can I show you here? Yes, paired sample, Wilcoxon matched pair rank test or sign test. It's always better to do Wilcoxon. Now, what if both the data, that is, before and after, both are categorical? Means, see, smoking status before treatment and smoking status after treatment. I would like to see, is there any difference? Now you cannot go for any parametric test, no paired sample t-test, no, because this is, both are categorical in nature. Smoking before and smoking after. So we'll go for McNamara test in data in the non-parametric test. So related sample, okay. Objective is the related sample. Then reset it, and smoking before and smoking after. Smoking before and smoking after, and go to settings. Now settings, in case if I customize test, so here is McNamara test. So in case if I click on McNamara test, I will get the McNamara, but I will ask SPSS to automatically choose the test based on the data. Let's see in case SPSS can do that for us. So run. Yes, SPSS is very intelligent. So it has actually chosen the test for us, and it samples related sample McNamara test. So the distribution of different values across smoking habit and status of smoking after treatment are equally likely. Means no difference. Both the distributions are absolutely same. No difference of the distribution. So in that case, that has got rejected. So we reject the null hypothesis and we say, no, there is a significant impact of treatment on smoking habit. Okay. आपका ये प्रश्न हो सकता है, तो सर smoking treatment, so after this treatment, like whether the people who smoked, they increased or they reduced. So make a cross tabulation. Make a cross tabulation, simple, and see. Okay, great. So this is how you actually do the paired sample t-test. Okay. Now coming on to the point wherein you use ANOVA, How do you do that? And which particular situation you use ANOVA? Anyone? Yes, yes, you are right. You are thinking right. So that is when one variable is continuous, and the other variable is categorical, but the categorical variable has more than two categories. Means you would like to compare more than two populations for a single parameter, which is continuous in nature. Okay. So how do you do that? You go to analyze. Okay. You go to analyze, and what do? And then you go to compare means and go to one-way ANOVA. This is what you used to do when you want to use ANOVA. Then you actually take dependent variable as weight and independent variable, that is the factor variable or categorical variable, as profession. You know that the factor, the SPSS calls categorical variable as factor variable. In the same fashion, R also calls categorical variable as factor variable. Okay. Okay. So, and then you actually go for OK. And when you press OK, you get the result of F test. But what we are going to do is we will go to non-parametric test, because what if weight is not normally distributed? We cannot go for ANOVA. What you'll do? We'll go for independent samples, and I will, I'll go to objective and customize analysis, automatically compare, whatever. It has nothing to. So weight is the test field, and instead of gender, we'll go for what? We'll go for what? Profession. Yes, because more than two categories. So in case if I go to settings and if I go to customize test, then I will go for, Kruscal Vallis one-way ANOVA K samples, Kruscal Vallis. So should I click it? No. So what I'll do, I will ask, SPSS to choose the result, to choose the test automatically, for us, and see whether it chooses Kruscal Vallis for us or not. Run. Yes, SPSS is intelligent. It actually has, selected Kruscal Vallis for us. Why? Because the number of categories in a categorical variable is more than 2. And here, we go for, so here 0.063 means null hypothesis accepts. So what is the distribution of weight is same across categories of profession. Yes. So weight is same. So there is no impact of any profession on the weight. So कोई भी profession आपका है, आपका weight same रहेगा. Means आपका weight पर असर नहीं आएगा. Okay. So this is something about, the one-way ANOVA counterpart or substitute of, parametric test, and that is Kruscal Vallis test. Talking about two continuous variable, okay, this, say calorie intake and weight. I would like to see that. So in that case, so these two variables are continuous in nature, and I would like to see the relationship. In case if they are normally distributed, I will go for correlation by variate. Okay. But in case they are not following what the normal distribution, we'll go for what? We'll go for the non-parametric counterpart of this Karl-Pearson coefficient of correlation, and either Spearman rank or Candle-Tau. So let's do that. That is also written here in the PPTs. So go to correlate by variate. Okay. So I would take calorie intake here and weight here both, and instead of Pearson I'll go for Candle-Tau. P. Or spearman. It's always better. Spearman is far better than camel top. P. Okay. Then press OK. Here is the result. Okay. If I see the coefficient of correlation, which is 0.313, so very poor, very weak correlation between calorie intake and weight, but it is very significant because the value is less than 0.05. Okay, so this is something. So null hypothesis is rejected, and then we have, it means that calorie intake and weight has got relationship. So this is all about non-parametric tests. Okay, so in case if I see Q&A, so many questions have been asked. तो ये ऊपर से चल रहा है, नीचे आना होगा. For mean comparison, do we go for median? No, for mean, Krishna, for mean comparison, we go for mean comparison. But in case of non-parametric, we do not compare means, we compare medians. Krishna Kumar, does the median get reported? Yes, you should. That is a very good question. People do not usually do that. Great. That's a very good question. Yes, median should be reported. Okay. Anjali ma'am, in case if someone is raising hand, you can ask them to,
Sir, sure, sir, we'll unmute them.
Yeah. So what is the difference between p-value and strength of association? Does p-value also shows that only? Anupama, let me tell you one thing. P-value has nothing to do with the strength. P-value has to do with the confidence level. In case if your p-value is less than 0.05, then your confidence level is 95%. But in case if your p-value is less than 0.01, then your confidence level is 99%. Okay, you got my point. So you are more confident that your confidence interval will reduce. Okay, so confidence interval will reduce means you are more sure that the value which will come will fall under this confidence interval. So वो जो आपने 6 sigma सुना होगा गुप्ता मैडम, अनुपमा जी, वो confidence आपने 6 sigma training सुना होगा ना, 6 sigma. So that is related to p value only. Yes, anyone else? Sir, how many cells with less than 5 expected count can be accommodated, or even if the single cell has less than 5? I need. Yes, sir, please.
Sir, I'm Dr. Sanjit Kumar Mandi.
Hanji, yes, Dr. Sanjit, please.
I am telling, if you permit me, I am telling about something.
Yes, Dr. Sanjit, please. Go ahead.
Sir, there is a question arising languages. But we are in higher education, we should accept the languages of Hindi and English. If when we teach about the regional languages, I would already know how to teach in our regional languages, but this is also emphasizing the language of English because our medium of language is English. So I am request all of the participants to does not question about the South Indian, North Indian, West Indian. We are all Indians, so does not making
no, Dr. Sanjeev, this is not the case. The thing is, sometimes what happens, it's like just poking it out. You are just picking it out. See, why even single line? Sometimes what happens, Dr. Sanjeev, you are speaking something in your flow, but you are also taking care of what like the kind of audience that you have. You have already taken care of that. But your flow and your flow, your style has to be maintained there. You got my points, Dr. Sanjeev. So the thing is, it's not about Hindi, English, or regional language. It is about your style. So what happens that I have already taken care of this language, so don't worry about that. And as far as English is concerned, I really like that. But this is the way, this is the style, because I really want to connect with all my participants. Let me tell you. Had I known the Odisha language, Mr. Sanjeev, I would have spoken that as well. Had I known the Tamil language, I would have spoken that because I would like to connect with my audience. And this is the way of connection, and that is the way, thing is, and teaching is an art. Okay, so it is a skill. So when you practice it, when you actually practice so many good things, you really connect with your audience. More is the connection, more is the download of the stuff. So this is something and nothing else.
Once a researcher or senior teacher can talk something, they well known about the languages and communication skills. We are not bothered about it, and not to hamper or disturb such a type
not to
of.
disturb. Yes, that's always been taken care of. You're right.
Okay. Okay, thank you. I request all the audience through your channel that all should be in broad-minded, and I feel that we are all Indians, not from
Sanjeev sir, you're absolutely right. Please, sir, if you have any question,
if you have any questions, then please,
Okay.
Yes, any other hand? Okay, so there is a question from Tushti. So Tushti, you have a very good question actually. You said that how many cells with less than 5 expected count can be accommodated? No, it is not the case of accommodation. It is just even if you have one cell of less than 5, then you have to be careful. Either if it is a 2 by 2 matrix, then you should go for Fisher exact test. In case if it is not, please increase your sample size, or there is something called correction factor, Yates correction factor, and there are other correction factors. You please visit few websites and find some correction factors. Some correction factors are being, considered by some reviewers, but sometimes they are not. So this is the key. So better is always increase the sample size, Tushti. Okay. Okay, great. What is the difference between chi-square test and cross tabulation? How to determine which should be applied? No, Dr. Sarita, I think you are right at the point, but just skipped one particular thing, and that is cross tabulation is the way of doing chi-square test. You first make cross tabulation. So what is cross tabulation? Observed frequencies of various categories. Now, on the basis of this observed frequency, you actually calculate expected frequencies, and then you make another cross tabulation of expected frequency. Then what do? You actually then you pick observed frequency minus expected frequency divided by gross frequency, calculate the value in each cell. Then you take the total sum of all the cells. Then comes the chi-square. So we cannot we cannot ask this question of what's the difference between cross tabulation and chi-square. We would say cross tabulation is the way of doing chi-square test. If there is cross tabulation, only then we can do chi-square. Otherwise, we cannot. Chi-square is not possible without cross tabulation. Okay. Test has 3 options: true, false, don't know. What is this? I do not understand. Firdaus, you need to elaborate your question. So why expected frequency should be less than 5? Tushti, it's a very big answer for this particular question. So we'll take it some time. That why? Because this is just entering into chi-square test and then the statistics of that. Okay. Yes.
Hello.
Yes.
Sir, can I ask a question? I'm Dr. Sandhya.
Yes, Dr. Sandhya,
I have
please.
a question regarding if a design is an experimental and controlled design, and if the distribution is normal, but the sample size is too small. So say like in the control group, we have 15 participants, and in experimental group, we have 15 participants.
Great.
Can we still use a parametric test?
Yes, absolutely. Because this is the biggest thing that you have achieved, and that is the distribution is normal. Okay, so 15 is not a matter of concern, because t-test is actually meant for the samples which have lower than 30 participants, 30 respondents. So that is okay. You should always go for t-test or a NOVA for that matter.
Okay, thank you, sir.
That's great.
So most of what you have told, I was able to follow, but I could not follow one specific point about expected frequency being less than 5. What is the meaning of that? What you were trying to say?
So expected frequency is something like, when you, may I know your name?
My name is Krishna Kumar.
Yeah, so Mr. Krishna, let me tell you, when I make the hypothesis of chi-square, means of two categorical variable, the hypothesis is the distribution of one variable is uniform as the distribution in the other variable. It has nothing to do with the different distribution. That is, it means that the one variable is absolutely random and the other variable is also random. So this is the chi-square test, okay? So this is the hypothesis. Now, uh, when you have some observed frequency, so what is expected frequency? Expected frequency is the frequency which says that had the distribution is uniform, had this data is random, then what should be the frequency?
Yeah.
Okay, so that is the expected frequency. Now, so the thing is, so what I've said, the frequency, see, the observed frequency is 16 and the expected frequency is, say, 9. It means there is some difference. The difference is huge. Okay, now say the expected frequency is 54 and the observed frequency is 53. You would say the difference is less. But if the observed frequency is 54 and expected frequency is 9, you would say, oh, there is a lot of difference. It means yes, something is going wrong. It means some biasness is happening. Okay, now, so you came to know. But when I would say the expected frequency is less than 5, it means data is not sufficient. It means data is not sufficient, Mr. Krishna. Yes, so it means what I need to do, I need to increase the data size. It means there is some category in your categorical data which has got very less numbers. For example, आपने एक data लिया and the data was of 100 people where the graduates are 70 and postgraduate were 25, but the PhDs were 5. Here is the problem. Since your categories are having very varied number, 75, 70, 25 and 5, I am sure that you are going to get expected frequency less than 5. Yeah, I hope that you got the answer.
Yeah, thank you. That during those times you would not be able to use this test, is what you're saying.
Yeah, yes, you're right, because not everything I can use and all. Yeah, that's great, Dr. Krishna. Thank you.
Good afternoon, sir. Good afternoon, sir. Can you hear me?
Hanji, ma'am, bataiye.
Thank you so much for your time, sir. I had a question. If I'm testing the awareness level on a certain issue, and is it possible for me to set the analysis such that I can get probabilities of getting certain questions wrong given a certain attribute in the sample?
Sorry, I did not get you because your voice is breaking. You please come again. Yeah.
Yes, sir. Suppose I'm testing for, let's say, financial awareness.
Okay.
And my data is now split into gender, so male, female.
Okay.
And I would like to know the probability of getting certain questions wrong, given that the respondent was a certain gender.
Certain question wrong?
Yeah. What is the probability of getting some question wrong, given the respondent was female?
Some questions wrong. Let's see, who is this? Can I know the name?
Firdaus.
Firdaus. See, now, what was your objective? Your objective was to check the awareness or to test the rightness or wrongness of your questionnaire?
I want to know whether gender is a factor in misunderstanding the issue.
Okay, see, Firdaus, let me tell you. So you are actually, you are mixing 2-3 things together. Okay. The first thing is when you want to see, if you want to test something, you must know how to measure that as well.
Correct.
Okay. So in case if you are not able to measure something, how would you test that? It's very simple. So how you are going to measure whether that particular question has been wrongly answered or wrongly understood or not? So
Correct.
this is a very big thing.
Yes,
So
sir.
this is now this is your research point of view, your research content, how you are going to find out that that how a particular question is perceived wrong. So this is you need to first do a kind of review of literature and find out how you are measuring, whether quantitatively you are measuring or qualitatively you are measuring, some psychological factor you are using. Only then you can talk about your hypothesis or some other test. Otherwise, it's not possible to, because you are first, on the one hand, you are saying you are checking awareness, and then you are saying what is the probability that one question is gone wrong. So when you talk about probability, so we actually talk about logistic regression. So it means the dependent variable is either right or wrong. So there are two possibilities, right or wrong. When the dependent variable has two possibilities, the right and wrong, and you have number of independent variables, then we go for logistic regression. Okay. So
yes, I mean, I'm happy that you gave this clue. I am looking at awareness, so it's factual. It's got nothing to do with psychology. So there is a right answer, there is a wrong answer, and then I could give the third option as don't know. But I got the hint from you, sir, that I can set it up after getting the answers, put it as right, wrong, and then do a logistic regression based on gender. I got that, sir. Thank you so much.
Yes,
Thank you.
thank you. Yeah.
Sir, I have a question. Can I ask, sir?
Hanji, ma'am, please, your name, please.
Sir, I am Deepashri Chatterjee from West Bengal.
Hanji,
sir, I have a question related to mergers and acquisitions. Actually, my studies on that. Now, suppose, sir, I just want to find out that whether a particular event has led to a new merger wave or not. Like, suppose if I want to find out that whether Companies Act, any Companies Act, or say, suppose I want to find out COVID-19 has led to a new merger wave or not. So, suppose I have the data for 2020, 21, 21, 22, and 22, 23, the number of mergers that have taken place in all these 3 years. But prior to COVID, I have categorized the years in a range of 10 years, like 1991 to 2000, 2001 to 2010, 2011 to 2020. Now, can I do this? Can I apply ANOVA in this case, sir? Because the first 3 years, first 3 categories have 10 years data, but the last category, post-event, has only 3 years data. So can I use ANOVA in this case, and
yes,
how to
absolutely.
use that
Yes,
in that
yes,
case?
yes. You can use ANOVA here, so there is no problem. However, there are two things. One is you, in both the cases, you have categorical data. Okay, Deepakshi, since you have in both the cases you have categorical data, so it's not actually event study. Okay, it is just the impact of one, say COVID as an event on the number of mergers and acquisitions. Okay, so in that case, you have both the in both the cases you have so you have two scenarios. One is before and second is after, and you have number of samples. So in that case, you will go for Kocher and Q test, which is a different aspect of non-parametric test, experimental research. Kocher and Q.
Be a non-parametric test, sir.
Yeah. Kocher
I cannot
and Q.
use ANOVA in this case.
No.
But actually, sir, I am asking because the literature that I have studied, there is a very famous literature. They have used ANOVA, and I could not understand why they have used ANOVA.
ANOVA cannot be used because what is the condition for ANOVA? One variable has to be continuous in nature. So which variable is continuous? You have both the variables as categorical. There is nothing called no figure is there. You got my point?
Yeah.
So no continuous. So if there is no continuous variable, how would you apply ANOVA? So now ANOVA is based on mean and variance. What is the full form of ANOVA? Analysis of variance. What is the variance in your data? Where is the variance? There is no variance at all because there is no figure, there is no numbers. So this Kocher and Q test, you have to test. That's a higher variant of non-parametric test. Kocher and Q. Okay. Yes, any other? Yes. Any other question? Okay, great.
I
No?
think Deepashri ma'am, your question is being taken care of. So can you please mute yourself? Sir, I think most of the questions been taken. There is one request by Anis Akhtar sir. He wants to ask you a question, sir.
Yes.
Anis Akhtar sir, please unmute yourself.
Yes.
Yes, please.
Hello, sir. Are you able to hear me?
Hanji,
Sir, thank you very much for your lucid explanation. Sir, while you are teaching, I have been practicing with regarding to non-parametric test. Okay.
That's great.
Sir, you have taught me analyze non-parametric test and then objective field settings. And you got the answer only one thing, sir, with regarding to the what you have taken, the variable you have taken. But when I was applying, I got nearly 8 points. Say, for example, the sequence of value defined by age category, unable to compute, and then the sequence of values defined by and then reject the null hypothesis. Like that, I have getting lot of information in that, sir. What mistake I have done, I do not know about this, sir.
Which particular test, ma'am, you have done? Thank you, Dr. Anil.
Sir, non-parametric test, age.
Non-parametric.
And one more doubt also I have, sir.
Yes, ma'am. Age is not the non-parametric test, ma'am.
Yes, sir.
What is the name? What is the name of that non-parametric test?
Yes, sir. One non-parametric, wait a minute, sir. I will tell you that. It is a non-parametric test, one sample t-test, sir. I have been taking weight after training preferences, sir.
No, so weight.
Smoking and the weight.
So smoking and weight, like in case if you want to take that, so which particular test you would like to go for, whether smoking affects weight or not, you would like to see that, na? In case if you want to see that,
yes.
So
yes,
you want to go for non-parametric test, so you should go for Mann-Whitney U test, because Mann-Whitney U test, is the counterpart of independent sample t-test. Okay. So should I show you how to do that?
Okay.
Let me show you.
Yes, sir.
Just a minute.
Yes, sir.
Can you see my screen right now?
Yes, sir, it's visible.
Yeah.
Yeah.
Yes, sir, I'm able to see you, sir.
Just go to non-parametric test and go to independent sample, because smoking is the independent, smoking yes or no are independent of each other. Just go to objective. So automatically go to fields, go to reset. Okay. Then go to weight here, and then go to smoking here, smoking in the groups, and then run, because everything is automatic. It will automatically use Mann-Whitney U test and see. Now the hypothesis is the distribution of weight is same across categories of smoking habits. Okay, means there is no impact of smoking on the weight of the person, which has got rejected. Okay, so it means that smoking affects the weight of the person. Okay. Yeah.
Okay, sir. One more doubt I have, sir.
Yes,
sir, I have been guiding the MPhil students for non-parametric test. Mostly the statisticians, they follow this way, that is analyze, non-parametric test, legacy dialogue, and under that, whichever is applicable, they are applying it. Is this way correct or not, sir?
It is absolutely same. It is one and the same thing in case if you go for legacy dialogues. Nothing else. It is one and the same thing. One sample, independent, binomial.
So we can use that also.
Yeah, yes, absolutely. No problem. It is one and the same thing.
Anything, sir, we have conglomerate and then white man, white native. So we can use either of these two methods, what you have thought and what it has been doing, isn't it, sir?
Yeah, absolutely.
Or any specific reason you have for applying, or something different answer we will be getting from what you have thought and what I have said, sir?
No, ma'am.
So that we can give some effective on our research.
No, ma'am. No, not at all. It is, this is the same test which I have done as of now. Like I have done one test, one independent sample test. So let me do the same test with legacy dialogue. Okay. So I'll go to non-parametric test. I'll go to legacy dialogue. I'll go to two independent sample. Okay, two independent. What are these two independent samples? One is the smoking habit. It is the grouping variable. So what are the groups? Smoking, yes or no? One. Yes. And group two. Okay, continue.
Male and female, 1 and 2, sir.
1 and 2. And weight is here. Okay. I think this is 1 and 2 only, smoking. Or is it 0 and 1? Oh, so fine. Let me check that. Fine. So, okay.
Okay. Anything else what we have done? Okay, sir.
So this is Mann-Whitney U test. If you see that now in this way, if you see there is a test statistics Mann-Whitney U test. So this is the value of Mann-Whitney U, and this is the value of their significance value, that is asymptotic significance, that is 0.00.
Significant, yes.
That is rejected. So this is as same as it was here.
Yes.
This is absolutely same.
As okay, sir. Okay. Yeah. Okay, sir. Thank you very much, sir. Thank you, sir.
Yes.
Thank you, sir. Thanks a lot for giving and such a wonderful explanation, sir.
Thank you, ma'am. Thank you so much. So nice of you. Yes.
Thank you so much, sir. And we are really grateful that you have undertaken a session on non-parametric test in such a wonderful way. You have explained in a very precise manner where the test and the subcategories should be used. And as you can see in the comment box also, sir, it's very much wonderful, and it's very much explaining in a detailed manner that you have done, sir. Thank you for such a session, sir.
This is just the
and
love
apologies, sir, that I have to make an interruption.
It's okay. It's okay.
Broke your
it's
flow.
Okay. Now see, it happens with me. So in case if I have said something which you did not like, I'm sorry for that. The thing is, I really when I teach, then I teach. I am really with my audience and all.
It's completely, yes, you are. I mean, it's going at the back of your mind what you have to do further. I completely agree with you, sir.
So everything actually got haywired. So I said, yes. Because I actually had made the things, and now this is then, and then this, and then this.
Right.
Because otherwise these audience will get confused. So so I request everyone to be be thorough about their statistics and all. So this is my personal suggestion. Okay. And my mail ID and my mobile number is also there. That's WhatsApp number. Okay, and thank you everyone who is actually writing very lovely words. Thank you so much, everyone. I cannot read these all the chats because there's so many. In case if I start reading it, it'll by night I'll be completing this. Okay, so thank you so much, everyone. This is just your love. Okay, and I wish you all the best. In case if I can be of any help to you all, just send me a mail or send me the WhatsApp message. Okay, thank you so much.
Thank you so much, sir. Thank you so much.
Thank you, Charu. You are Charu or something?
Yes, sir. Yes, sir.
Thank you. Bye-bye.
Thank you. Just an announcement for the participants. The next session is scheduled on Monday, 28th of December. Tomorrow we do not have any scheduled session. Thank you.